Okay.
Yeah, I think so. Yep.
Okay, let me share the screen. Can you see the screen?
Yes.
Okay. Okay, so second question type on factorial is, so that day we did n factorial. So this is n factorial plus 2 to n factorial plus n. So I'll show you a question. Yeah.
Which one?
Question number 10.
Hmm.
So what do you understand by the question?
I haven't even gotten to statement two. It looked a little confusing. 13 fact. I'm still reading it. The only thing I understand. Huh. So let's see. Like the state. So it says that does K have a factor P such that P lies between 1 and K?
Hmm.
Obviously K is greater than P and P is greater than 1. Statement 1 is saying that K, the value of K is
So what is the exact meaning of the question? In data sufficient problems, you have to rephrase the question to say something meaningful.
oh, you mean can P divide K such that P lies between 1 and K? What is that?
So the question actually means, is K a prime number or not?
Hmm.
Does the integer K have a factor P? If there exists such a factor, then K is a composite number. If there is no such factor, then K is a prime number. The answer, the question asked is in a yes or a no. So it is simply asking whether K is a composite number or a prime number.
Okay, fine. Um, so if K is a prime number, then P cannot divide K.
Correct?
Um,
In that case, there will be no such factor P. And
yes,
if P divides K,
then
then
K is
then
not.
K is not a prime number.
Yeah, I agree. So in statement one, it's saying that K is greater than 4 factorial, which means that K, I mean, K can't obviously be prime, right?
Perfect. So K greater than 4 factorial means K is greater than 24.
Yeah,
Now, greater than 24, we have composite numbers as well as prime numbers. So we cannot give a definite yes or a definite no.
yeah.
That means the statement gets rejected.
So it's insufficient.
Correct.
And then the second statement says 13 factorial plus K lies between 2 and 13 factorial plus 13.
Hmm.
Okay, let me just try and understand what this is saying. It's saying that, well,
So it is giving you a list of 12 integer values,
For
starting from 13 factorial plus 2 to 13 factorial plus 13. So the question is, in these 12 values, does the integer k have a factor p such that basically is k prime or composite in these values?
um, okay, hold on. So 13 factorial is okay. It's 1 until 13. Um, Plus k can have any values between 2 and 13 inclusive, plus 13.
So k is the complete value. 13 factorial plus 2 is the value of k.
Oh, you know how I'm reading this? Yeah, that's probably what happened. I was reading it wrong. K lies between 13 factorial plus 2 and 13 factorial plus 13.
Yes.
So K can have values. I don't know what that means. K lies between.
Okay. So okay. So let's discuss this question. Now, what is 13 factorial?
1 into 2 into 3 up to 13.
Correct. Now, since 13 factorial is a now this number shows that 13 factorial is a multiple of 2.
Yes, and okay. So,
So 2 is a factor of 13 factorial,
yeah,
right? So I can write 13 factorial as 2n.
yeah, plus 2.
Now, if 13 factorial is 2n, what is 13 factorial plus 2? It is 2n plus 2.
Yeah, which
I
is,
can take a 2 common.
yeah, 2 into n plus 1.
Now, when I'm writing n here, it means an integer value. To an integer value, if I'm adding 1, that means this complete n plus 1 will be an integer value.
Yeah,
2 into some integer value. That means 2 is a factor of 13 factorial plus 2.
yeah.
That means 13 factorial plus 2 is not a prime number.
Hmm. Um, it is not a prime number. One second, sorry.
Prime number means only two factors, 1 and the number itself.
Yeah, 2n plus 2. So you're adding, but I can also look at it like this, right? At that step of 2n plus 2, I can think of it like 2n plus 2 is not prime.
Means,
I mean, n is an integer, I know that, right? But isn't 2n plus 2 just not a prime because it's 2 into integer plus 2? There's no
yeah.
prime that
For
exists.
example, 2 into 4 plus 2,
Yeah, it'll be 10
8
instead.
plus 2, 10.
Yeah, not prime.
It will never be prime.
Yeah,
And there is a property that says, if for example there is a number n, so na, that is a multiple of n, plus nb, another multiple of n. If I add these two numbers, I will always get a multiple of n.
yeah,
So to two multiples of 2, if I'm adding these two multiples, I will always get a multiple of 2.
Yeah.
That means a number will never be prime.
Yeah.
Now,
13 factorial plus 13.
13 factorial plus 3.
Plus,
If 3 is a factor of 13, then I can write 13 factorial as 3n.
yeah.
So 13 factorial plus 2 will become, 13 factorial plus 3 will become 3n plus 3.
3, yeah.
I can take a 3 common now. Again, since it is a multiple of 3, it cannot be prime.
Yeah.
And I can do this with all the multiples.
Yeah.
I can write it as 4n plus 4 because 4 is also a multiple of 13. I can take 4 common. That will also not be prime. And I can do this till 13. 13 factorial has 13 as a factor. So this is a multiple of 13 as well. And to a multiple of 13, if I add 13, I will get a multiple of 13 only.
Yeah.
Again, not a prime number. So that means in the entire range, none of the numbers can be prime.
Yeah.
Every single number is a composite number.
So X is a composite number.
So all the numbers, K is a composite number. Starting this to this, every single number is a composite number. None of the numbers can be prime.
Yeah.
So in general, starting from n factorial plus 2 to n factorial plus n, none of the numbers can be prime.
Can be prime, okay.
Right?
Yeah.
Okay. Okay. So now, first question type is about n factorial. Second is about n factorial plus 2 to n factorial plus n. Only number missing here is n factorial plus 1. That is the third question type. Let's say the question is, we need to find the smallest prime factor of 50 factorial plus 1. Or we can say, instead of finding it, the smallest prime factor of 50 factorial plus 1 will lie in the range 2 to 15, 16 to 30, 31 to 40, 41 to 50, greater than 50. How will you do this? Prime factor means factor which is a prime number in itself.
Yeah. Okay, so we hold on. So first of all, we're clear that, I mean, I'm thinking, I'm trying to take a smaller number like 4 factorial plus 1.
Okay.
And
so
with that, then
let's make it, instead of 50 factorial, let's make it 10 factorial. The answer choices will change, obviously.
Yeah, of course.
The reason why 50 factorial is 10 factorial is also fine. You should not be able to calculate and find the value of 10 factorial. If the value of 10 factorial can be found, then the purpose of this question gets defeated. You have to figure out the logic behind this.
Yeah, yeah. There's no doubt about like that. I just don't. This knowledge. You're adding one to a number.
It should be done with the same logic. Now we can say that since 10 factorial has 2 as a factor, I can write 10 factorial as 2n. And if I'm adding 1 to 2n,
It's an odd
can
number.
I divide this number by 2?
No.
No, not divisible by 2.
Yeah.
And since it also has 3 as a factor, I can write it as 3n plus 1. Can this number be divisible by 3?
No.
No. Similarly, 4n plus not divisible by 4. And it goes on till
10.
10n plus 1 not divisible by 10. That means any number from 1 to 10, so from 2 to 10, or basically 2 to n, cannot divide this.
Oh, so it has
So
to be greater than n.
yes, we are not sure if greater than n there will be any such number, but if there exists such a
Then
number,
it
then
must be
it
greater
must be
than.
greater than n.
Yeah.
Make sense?
Yeah. Yeah.
Okay.
I mean, it makes sense when it's like I don't know. I mean, I have to learn to now put it in this format, and I think that'll come with practice, hopefully.
Yeah, that's right. There's a question similar to this that uses basically the same concept uh, in the official guide. Question number 77.
So is it 17 only? See?
Perfect. Very good. So what's the logic?
So I thought of this as n factorial plus n. So that would mean that n factorial plus n is divisible by n. And then 17 factorial plus 17 is divisible by 17.
Very
Um,
good.
Now, if you take 15, um,
Hmm.
20 factorial is divisible by 15, but 17 is not.
Correct. So 20 factorial can be written as 15n
Yes.
because 15 is a factor of 20,
Yeah.
and 15n plus 17 will not be divisible by
By
15.
15. Same with 19.
Similarly, 19. Correct. Very good. Okay. Now, know all the divisibility rules.
Or you mean like 2 is a number is divisible by 2? Right?
Yeah.
Well, 2 is. pretty straightforward. All, I mean, any number that ends in a two or four,
Yes. So
zero,
it depends on the units place.
yeah, 0 to 4. I mean, if it's a even number, then it's divisible by two.
Yes. Units place digit should be even.
Yeah. Uh, 3 will be anything that adds up to a 3
Yes. So sum of the digits.
is divisible by 3.
Correct.
4 is 2n, right?
Means
Anything that's divisible by 2 into, no, that's
last two digits should be divisible by 4.
oh, okay. I did not know that. 5
5.
ends in a 0 or a 5.
Very good. Again, units place digit.
Yes, you know, what is
For 6.
I mean, it's obviously it has to be 2 and 3 divisible by 2 and divisible by 3.
Perfect. That's it. So divisibility rules for both divisibility rules of 2 and 3 apply. 7 there is no need because the divisibility rule of 7 is actually difficult and actual divisibility by 7 is easier. So we
Sorry?
generally divisibility rules we actually study just to make calculate things faster.
Yeah, yeah, yeah. That.
So 7 the divisibility rule is not good. It actually takes a lot of time.
Hmm.
So in lesser time you can actually divide the whole number.
Yeah, you're right.
For 8,
8. Is this unit space or I don't know actually. 8.
last 3 digits should be divisible by 8.
Oh, so similar to 4.
Yes. For 9,
9. We uh, some of the digits should be divisible by 9.
very good. 10 is easy.
Yeah, 0.
Units place only.
Yeah, unit stay 0 and 11. What is 11? I mean, 11. Oh, sorry.
For,
No, it's like 33, and I mean, they're like, well,
so for 11, let's say the number is 2, 4, 6, 8. So 1, 2, 3, 2, 2. This is the number. Or 1, 3, 2, 1. Basically. Yeah. This is the number. Then what do we have to do? Start from position 1 and add alternate digits. 1 plus 2 plus 3 plus 2 plus 1.
9.
Yes. And now add the remaining digits.
4, 5, 6, 6, 6, 20.
Now, if the difference is 11 or a multiple of 11,
Oh, then the number is
yeah,
this
or
is
even 0.
for me.
Number, the difference can be 11 or a multiple of 11 or 0.
Oh,
Then the number is divisible by 11, otherwise not. Okay. So, have you ever heard of cyclicity?
I think like it should.
We use cyclicity basically to figure out, excuse me, to figure out if we have, for example, there is a question in official guide that says 33 to the 43 plus
Oh yeah.
43 to the 33.
Hmm.
How can we solve this? We need to find the units place digit of this number.
Oh, I think I know what it means. It means like two to the power. So suppose you have like the number of two, like number of threes. It requires um like mm, to get I don't know actually. That's fine. We can get.
So we use cyclicity to find the units place digit.
Yeah.
Now, let's say the number is 33. Now, if I multiply 33 two times, 33 by 33, what should I get as the units place digit?
9.
9. So you instantly jump to a conclusion. It will be 9. So, and what will happen if I multiply 133 by 133?
9.
9. That means to find the units place digit, I require only the units place digit of the number. Other digits can be ruled out.
Yeah.
And in this case as well, right?
Yeah. So you can
So
rewrite
the
it as
question essentially becomes 3 to the 43 plus 3 to the 33. Okay. Now, how can this question be solved? 3 to the 1 will give you 3. 3 to the 2 will give you a units place digit of 9. 3 to the 3, very good.
and 1 will come only when it goes to 3 to 4.
Yes.
4 is a cyclicity of, no?
Yes. Perfect.
I
Now,
didn't know.
when we go to 3 to the 5, we again get the units place digit of 3.
So
So
it,
that means after every 4 exponents, the units place digit of 3 starts repeating itself.
hmm.
So the cyclicity of 3 is 4. Okay. Now, if cyclicity is 4, we have found this.
I know what
How
you
can we?
mean. So you'll
Yes.
rewrite 43 in,
Hmm.
adding to like in the division forms of like, um,
Okay.
so it'll be 43 divided by 4.
We get
Uh,
10 3 by 4.
yeah, yeah. So it'll be 4 into 10 plus 3.
Hmm.
And then, so then 3 to the power of 40 into 3 to the power of 3,
Correct.
right? And then 3 to the power of 40 just becomes, mm. Oh, and then yeah, you can rewrite that as 3 to the power of uh, 3 times 10 plus 3, which is 3 to the power of 30 into 3 to the power of
3 to the power.
3. Not, do you divide that also by 4?
Yes, correct.
Okay. Uh, so it becomes 8, na? 8 to the 32, and then 1 is the remainder. 8 times 4 plus 1.
Hmm. So what does the rule say? The rule says if we have to divide how to change the knowing cyclicity, how to change the exponent. The exponent here is 43. We divide by the cyclicity of the number
Yeah.
and we get a remainder of 3. Change 3 to the 3, change the exponent of 3 with the remainder.
Because 3 to the power of 40 means the units place becomes 1.
Yes,
So only 3 to the power of 3 is left for the units place.
correct.
Yeah, plus 3 to the power of 1.
3 to the power of 1.
So 8 becomes
So 3 to the 3 will give the units place digit of 7.
plus 1.
3 to the 1 will give the units place digit of 3.
3, 3, yeah.
So we will get a 0. Right?
Yeah. If you can give me another question, I'll try and.
Yeah. So actually, this question doesn't check all the concepts of cyclicity.
Yeah.
Okay. So, okay. So I will write, I will draw the table here. The table you can maybe use. This is first column is for the number and second column is for the cyclicity. It's good if you remember all of this, memorize this. 2, 3, 4, 5, 6, 7, 8, 9. The cyclicity of 2 is 4, 3 is 4, 4 is 2, 5 and 6 it's 1, for 7 it's 4, for 8 it's 4, for 9 it's 2.
So 0, 1, 5, and 6 are the numbers, now. Like, basically, you stop, you get to the cyclicity. Suppose I forget how to. I'm just making sure I know how to calculate cyclicity. It's basically as soon as you get 0, 1, 5, or 6 when you're taking the power of numbers.
0, 1, 5 or 6. Now what does that mean?
That means.
Yeah. So you don't have to worry about the cyclicity anymore for these numbers. Numbers ending with 0, 1, 5 or 6. Uh,
No, like now, why is the cyclicity of 2 4? It means, so 4 is the exponential power of 2 that gives you 6 as the units place, right?
okay. So 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. So after 4 numbers,
Yeah.
the digits, units place digit
Okay,
starts
it
repeating
starts
itself.
repeating. So as soon as it starts repeating, you're
Yeah. When we check for 5, 5 to the 1 is 5. 5 to the 2 is, it also ends in a 5. So that means the cyclicity is 1.
okay. But I still need to know the number 6, right?
What is number 6?
Like 2 to the power of 4 is equal to.
Yeah. So see, for first, whatever the cyclicity is, uh, it even if it is 2 to the 4, so that you can very quickly
Yeah. I
calculate
understand.
as well.
Calculate. Okay.
So only knowing the cyclicity is sufficient.
Hmm.
So
Is it 1?
Okay.
No.
So what will you get from 2 to the 28?
6.
Very good. 3 to the 76?
1.
Very good. 9 to the 23?
1.
Why?
9 to, so 23 divided by 2 gives you a remainder of 1.
Correct. Now, remainder is something that you replace the exponent with. So in place of 23, you
Oh,
can
yeah.
write 1.
1. Oh, so 9 plus
Hmm. Correct.
remainder
So 6 plus
plus 45.
5. So you will get 1.
Acha, you just taken 9 5 of 45 and taken the 1. I mean,
Yeah.
taken,
So we are interested only in knowing the units place digit.
yeah.
Okay. This is clear?
Yeah.
Okay. Very good. Okay. Now, if okay, I have a number like fraction like 7 over 5.
Yeah.
If I divide 7 by 5, what will happen? I will get some quotient
Yeah. And the remainder.
and I will get some remainder. And this is my divisor. So how can I express this fraction? This fraction is expressed as quotient remainder over divisor.
Yeah. 1 2 by 5.
Correct? Right?
Yeah.
Okay. Now, question number 95 of the official guide says, if x is divided by y, then the remainder is 9. And the value of x over y is 96.12. Find the value of y. How can we do this?
So the remainder plus or remainder of a device is equal to 12 by 100.
Remainder over divisor.
Is 0.12.
Yes, very good.
So 9 over y is equal to 12 by 100. And then we can.
Very, very good. Perfect. So basically it is that when we stop at remainder, then we get a mixed fraction. If we continue with the division process, we will put a decimal and we will borrow a 0 here,
Yeah.
and we have then to
So you're
we can,
converting the r by d into the decimal format.
yes, correct. Perfect. Okay. Now let's say I have fraction 7 by 5. Now this is 1 point equal to 1.4,
Yeah. 0.4 is that 2 by 5.
and 7 by 3 is 2.3333, and it goes on, right?
Yeah.
Okay. How can you look at the fraction and tell whether we will get a terminating decimal or a non-terminating decimal?
Hmm. I actually don't know.
Okay. The rule says if only twos and fives are present in the denominator.
Then you get terminating.
Correct. Then terminating decimal. For every other number, it has to be a non-terminating decimal.
Yeah.
Make sense?
Yes.
Okay. Now let's say we are given t is equal to 1 over 2 to the 5 times 5 to the 9. So if this number t is converted to a terminating decimal, then how many non-zero digits will t have?
So 2 to the power of 5 into 5 to the power of 5 will, and then don't we have 5 to the power of 4 that's remaining?
That is correct. So we can say that 10 to the 5 into 5 to the 4.
Yeah. 10 to the, um, so how many, so 27,
Non-zero digits will t have?
so
T
27,
means the terminating decimal.
okay. So this becomes 1 over um, 625,
Correct.
and use, and um, this 1 over 625 is this one. So that's a terminating decimal, right?
That is a terminating decimal. Yes, that is given to us as well. If
Okay.
t is equal to this, a fraction value is converted into a terminating decimal. Then once this is converted into a terminating decimal, how many non-zero digits will t have?
Non-zero digits. Isn't it 3?
How?
I mean, the 10 to the power of 5 will keep giving zeros. I mean,
Yes, correct. So 10 to the power anything, whether we multiply or we divide, it will not change a thing. It will just move the decimal place either to the left or to the right.
yeah.
So it's all about
So 625.
625.
But am I supposed to divide 1 over 625 and see how many, or do I just
Yeah. So the point is, you can do that. 1/625, you can actually do it, but that is not advisable.
Yeah, it's a long. I mean, it'll take me lots of zeros to get a number.
Yeah, correct. So what is the best way? If t is equal to 1/2 to the 5 times 5 to the 9, we know that a 10 is 1 2 and 1 5.
Yeah,
Now the objective should always be to minimize the calculation. Now we have 5 twos and 9 fives in the denominator. If I supply 4 twos like this, so that is, I am not changing anything. It's just
no,
by multiplication by 1.
yeah,
So I will have 2 to the 4 in the numerator, and I have 9 twos and 9 fives in the denominator. That will give me 9 tenths.
yeah.
And 2 to the 4 is 16.
Hmm.
That means I will have only 2 non-zero digits.
Oh, okay. I would have never. I mean, this is.
But this makes the task very easy.
Yeah, for sure. Basically, you try and yeah, you're minimizing. Hmm.
Your objective should always be to reduce calculation, and calculation can be reduced only by making denominator as a value which has zeros only.
Yeah,
Okay.
I have to learn this.
Yeah. You can try this question. If t is equal to 1/2 to the 9 times 5 to the 3 is converted into a terminating decimal, then how many zeros will t have between the decimal point and the first non-zero digit to the right of decimal point? You know, one of my students got selected into Harvard yesterday.
Really?
Yeah, she's also in US.
What is her background?
So she is working with Carlyle Group.
Oh, in DC? No.
Yeah, yeah, in DC. So she is actually in Atlanta, but she has to travel to DC all the time.
Yeah, that's a really well-known. I have my cousin is a she's the head of business development at Carlyle, who also actually went out. Um,
Okay.
HBS is a hit or miss. It really depends which year you apply, what like class they're looking for. I know some people who I'm surprised that they got in.
That is true, but see, if your overall profile is good and your score is good, then a lot depends on how you present your application.
Yeah, could be. I mean, it's also like, I mean, uh, there are people who have a good profile of like consulting, Ivy League, and it could be that that year they have too many people in the same quota of consulting with a good profile.
Yeah, so actually, a very good GMAT score, generally people from consulting and maybe IT or maybe finance background,
Mhm.
they are actually the most competitive pool.
Yeah.
But a lot also depends on the applications. Like one of my students a couple of days back, he got a scholarship of 40%, $40,000 from UCLA,
Okay.
and he applied last year and he got rejected. He did his applications with some consultant last year, so he got rejected most of the places.
Hmm.
But this year we prepared his application, and he converted Kellogg's a week back, 10 days back. He converted INSEAD, he converted UCLA now. So I figured out like a lot also depends on the application.
Yeah. Yeah. It
A
really.
good GMAT score definitely helps a lot. But when a lot of people are scoring 700 plus scores, then the
Yeah.
application also has to be
That
very
that
competitive.
would be very, yeah, that's the thing. I mean, I kind of want to, hit that, decent GMAT score, so at least that category is taken care of before I focus on
Correct. That's
other
right.
things. So, um,
Yeah. So if a not so good GMAT score and a decent application uh, will not help.
yeah. Um, yeah, I haven't even gotten to thinking about applications. I was just, I mean, the thing is, I mean, I was speaking to someone who's in the admissions team at Columbia yesterday, actually. Um,
Mhm.
and so I may consider the executive program at Columbia. I really want to apply to HBS Columbia executive program. So obviously, if I get HBS full time, then I would consider it. But because I really like the job that I have, it's difficult to say that I want to give up my job to do a full time program.
Yeah, that makes sense.
Also, just expensive. Um, is
That's
it?
true.
Yeah, is it 4 zeros?
It is 4 zeros. That is correct. So how you arrived at this?
I did it a little lengthy, but I did multiply and divide by 5 to the power of 6.
Correct.
And then in the denominator, you get 10 to the power of 9. Numerator, you were stuck with 5 to 6, which is 625 into 25.
Yeah. Or what you can do is 5 to the 6 can be written as 125 into 125,
Yeah.
and it is like square of a number ending with the 5. So how do you do that?
Square of the number.
Square of a number ending with a 5. So for example, how will you do 45 into 45?
You mean just multiply it? I,
Okay,
what do you mean?
uh, just give me a sec.
Yeah.
Yeah. So actually, number with a 5, if you square them, so it is actually a very good technique that you can follow. 5 times 5 will give you 25, and whatever you are left with on the left, multiply that with its successor, 4 by 5. So you get 20, 25.
Yeah,
Is it?
yeah. I've never seen this before. This is what they should have taught us when we were multiplying 45 into 45 in class 5. I mean, like, you know what I mean? Like, I don't understand why they made us do the long method if there was a simpler method.
Yeah. So for example, 105 times 105.
Okay,
So
so
25 and 10 times 11. 10
11.
times its successor,
Yeah,
110.
Yeah, 110. I will try and remember this. There's so many stuff with so many rules to try and remember.
Yeah, so 125 into 125, you will get a 25 at the end, and then 12
12
times
versus
13.
13.
That will be 156.
Yeah.
So 5 tens will be consumed, 5 zeros will be consumed in these 5 digits.
And four
So
zeros.
remaining will be 4 zeros. Right?
Hmm.
Okay.
So do you you live in Atlanta or do you confused?
So actually, my company is in India and it is in US as well, in Atlanta. So I am right now in India. Maybe next month, I'm I will try to push it a little more, maybe at the fag end of Jan, but I may have to go around middle of the Jan as well.
Okay.
Okay. Now, we have discussed that if a number starts repeating itself in the decimal number, then we put a bar over that number.
Yeah.
So, for example, the number is x is equal to 0.023 bar. The question comes that this is a decimal, recurring decimal. Convert this into a fraction. How can we do this?
Hmm. So it's yeah, that's I don't know how to do it. Because it's 2 3 2 3 2 3 it keeps going on. Um
Yes.
so you can how do you rewrite it though? I mean it'll be over you know.
So basically, to convert a recurring decimal into a fraction, it is a three-step process. Where step one is multiply both sides by 10 to the n, where n is equal to number of digits between the decimal point and the first digit under the bar. So in this case, in the example that we are doing, it is n is equal to 1. Therefore, multiply
10n ho gaya and then
by 10.
yeah, so it becomes 10x is equal to 0.23 bar.
Yes, 0.23 under the bar. Okay, that is your equation 1, right?
Yeah.
Okay, now step 2 is multiply both sides by 10 to the m, where m is equal to
The number of repeating.
number of digits under the bar.
Yeah. So 2.
Correct. M equal to 2 means multiply by 100.
So, 1000 x is equal to 23.23.
Very good. 23.23 bar. Now this is our equation 2. Step 3 is subtract
One,
equation 1 from equation 2. That is 2 minus 1. So you will get
900.
990x.
Yeah, 990x is equal to 23.
Yes. So now you can write the fraction. 23 over 900.
990. Yeah, I would have never known how to do this like this.
Yeah. So ultimately the objective is to get rid of the bar. So how do we get rid of the bar? We first bring the decimal point just before the bar and then multiply by the number of digits under the bar, so that the second equation will also give us the same number of digits after the decimal point, the same value that is under the bar. And when we subtract these two, we will get rid of the bar.
Yeah.
And there's a very good question. Shall I erase the screen?
Yeah, yeah.
Okay. There's a very good question given in the official guide. I think 150 or something. Yeah, 150. You can try this question.
Let me go. अच्छा, so but I shouldn't try it with my. I mean, ये तो means simpler है ना, क्योंकि it's just 10 to the power of 2 into 0.0012 bar, and
Hmm.
then you just shift the decimal place by 2,
Hmm.
so it gives you 0.1 0.12 bar.
Now the people who design these questions on the GMAT, they are extremely clever.
Yeah, they were
Now,
expecting you to do that.
yeah, so they actually they have asked the whole 3 steps in just this simple question. They have
Wow.
actually executed all these steps.
Oh, you mean in the answer choices?
The way that they have designed this question, if I have to open this, how should I do?
Oh, you have to take out 10 to the power of 2, and then in
Point
bracket.
zero zero one two bar?
Oh, you're just doing the 0.0012. Okay, fine, fine, fine. One second.
Yeah, 10 to the 4
One second.
into this.
Yeah,
Yeah,
one second. So first step is you multiply by the number of, so you first do 10 to the power of 2. So let x be equal to 0.0012 bar. You multiply x by 10 to the power of 2 into x is equal to 0.12 bar. This is equation 1. Second step
correct,
will be again multiply by 10 to the power of 2. So it becomes 10 to the power of 4x is equal to 12.12 bar. And then
correct.
2 minus 1 will be 10, 1, so 10,000x, right?
Hmm.
Is equal to 12.12 bar minus 100. So it becomes 9900 is equal to 12. 9900x is equal to 12. X is equal to 12 by 9900.
Very good. And 10 to the 4 minus 10 to the 2 is 9900.
Yes. So 12. Yeah.
Yes.
Really? trick you. But what I would have done was 10 to the power of 4 minus 10 to the power of 2, rewrite that as 10 to the power of 2. Oh, so you would only get 9900.
Yeah.
And then what would you do? Multiply or
So now, whatever we have done, ideally we should not have done anything. Usually you should give yourself another 5-10 seconds to understand the question, why they have given or framed the question like this. There must be a reason, because these people are extremely brilliant the way they design the question.
yeah.
Now 10 to the 4, if I multiply, open the brackets and multiply directly with 0.0012 bar,
Acha.
what will I get? I will get 12.12 bar.
12 bar minus 0.12 bar.
Yes.
Yeah.
So this is basically step 1.
Yeah.
This is step 2, and subtract step 3.
So,
So
but
they have actually executed the all 3 steps in a single
do
statement.
you think what did they just work backwards when they made this question, or they just
Yeah, correct.
yeah. Um so this is like a what? A 600 level question?
So this is like you can say yes, 600 to 650 level question, correct. You can get a fair idea by looking at the question number. A
Yeah.
question maybe in the first 150 or first 50, it is like roughly 500 level question. Above 150, it is above 600 level,
Okay.
and above 200, it is above 700
Fine.
level. On the GMAT, the most difficult topic is inequalities. And when GMATs really want to test you, the next most difficult topic they consider is coordinate geometry and then combinatorics. So there is a question, question number 228 on the official guide. Now, on this question, they have actually done mixed all these things. They have introduced inequalities, they have introduced coordinate geometry, and they have asked you to calculate how many possibilities are there. So they have included combinatorics, inequalities, coordinate, everything. This is perhaps one of the most difficult questions ever asked on GMAT.
They won't even show me this question. So it's fine. I wouldn't even waste my time right now trying that.
Okay. Okay. So this is fractions. Now there is okay. Let me show you the question. This is like complicating the question. The question is easy, but the way this question is set up makes it
Which one?
slightly difficult. Question number 218.
Oh my god, okay. List T consists of 30 positive decimals, none of which is an integer, and the sum of the decimals, 30 decimals, is S. Estimate its sum of the 30 decimals. E is defined as okay, each decimal in T whose tenth digit is even is rounded up to the nearest integer, and each decimal whose tenth is or rounded down to the integer. So E is the sum of all these. So E is the sum of all 30 integers.
E is the estimated sum of all 30 decimals.
Integers.
We can say integers, yes.
Okay, because you're rounding up and rounding down. E is the sum of the resulting integers. If 1/3 of the decimals in T have a tenth digit that is even, 1/3 is even. What which of the following is a possible value of E minus S? Okay, so suppose you take point zero two is that the it's the tenth digit is even, right? I'm just taking an example.
So 0.02.
Yeah, that's like a decimal in T whose 10th digit is even.
No.
Oh, sorry,
So
10th digit is so it'll be 0.20.
yeah.
Yeah,
So 1, 2, 3, decimal 4, 5, 6. This is units place,
yeah,
tens, hundreds.
yeah. And that becomes tens directly. There's no units. There's tens, hundreds, thousands.
No.
Oh, four is what?
So the way you pronounce is wrong.
Tenth is tenth.
Before the decimal, when you see the digits, when you speak, it is ending with an S.
Yeah, that's TH
Units.
on the other side.
This will be TH, tenth.
Yeah,
This will be
tenth,
hundredth.
hundredth.
So if it is ending with the TH, they are talking about digits after the decimal point.
Yeah,
And before TH, before decimal, they will say ending with an S.
yeah.
Okay.
So you're rounding up or rounding down for even?
For even, we are rounding up, and odd, we are rounding down.
Okay, so 0.20 becomes 1.
0.20 becomes 1. Correct.
S is the sum. So estimated sum minus sum. of the three decimals. I don't know how to do this. This is, I guess it's,
So, what should be the right approach to solve such a problem?
I mean, I guess you have to start thinking of concepts that you studied. So, say, obviously, rounding, I mean, decimals and what the properties could be. I mean, I don't know.
Now, when they are saying S is the sum of 30 decimals, so
Yeah.
when we have to find the sum of decimals, it will be the actual sum.
Yeah.
And when we are saying that E is the estimated sum, so they have given the process of estimation. And we are also given that 1/3 of the decimals in T have a tenth digit that is even.
Yeah.
That means out of 30, 10 are even
Yeah.
and 20 are odd.
Yes.
Now, every even is rounded up. That means whether it is 0.2 or 0.4 or 0.6 or 0.8,
Yeah.
we will round up to 1.
Yeah.
And there are 10 such numbers.
Yeah.
So
Minimum
we
value
will get
10.
a total of 10.
But
And
what if it's 2.3?
yes, now that is the right question you asked. If it is 2.3, it doesn't make a difference. Why? Because 2.3 we will round up to make it 3.
No,
But
we
for
have to
ease,
round down into.
no, for even we have to round up.
No, but 2.3.
Yeah, 2.3 will come down. Yeah, it will become 2. The only thing is 30 positive decimals, we have to make our life easy.
Yeah,
And that we can do by choosing decimals between 0 and 1.
yeah,
Why? Because end of the day, we have to calculate E minus S.
yeah. So it doesn't matter if
The
we,
difference between the two will always be the same. Whether we do 203.3 minus 203 or we do 0.3 minus 0,
oh, okay, the difference will be the same.
difference will be the
That's
same.
why it is easier numbers.
Yeah. So that is why we will consider only those numbers between 0 and 1.
Yeah,
For all the odd tens, 0.1, 0.3, 0.5, 0.7, 0.9, we have to round down. That is, all these 20 numbers will become 0.
yeah. Okay, so 10 plus
So
0.
10 plus 0. So we have a definite value of E.
Yeah,
E is 10. But when it comes to, now it doesn't matter which number we have, zero point 0.2 or zero point 0.4 or zero point 0.8, we will get a 1. And for all odds, we will get a 0, irrespective of whether we have 0.1 or 0.9.
yeah,
But this will matter when we do calculation for S. Now, when we are calculating for S, we will have a whole range of values.
yeah,
So what we can do is we can figure out the minimum possible value and the maximum possible value. Other than that, we cannot do anything.
yeah. With S, it's going to be a process, no? Like
Yes.
point. Hmm.
So what is the minimum possible value of S? We consider 10 even tens to be 0.2. And we will consider 20 odd tens to be 0.1. This way we will find minimum value of S. And maximum value of S, we can consider all even tens to be 0.8
Yeah,
and
10,
all,
10,
yes, zero point 0.9. So this will be 2 and this will also be 2 for minimum, means 2 plus 2 is 4. And when we are finding maximum, it is 8 plus 18, which is 26. Now we can find the difference. 10 minus 26, E minus S will be 10 minus 26 or 10 minus 4. This will give negative 16 and this will give 6.
yeah,
So this is the minimum possible value of E minus S and this will be the maximum possible value. So which of the following is a possible value of E minus S? Negative 16 is a possible value. Positive 6 is a possible value. But it cannot go move beyond 6 in the positive direction. So 10 is not a possible value.
yeah. Because E is 10.
Yeah, E is 10 and S will always be a positive value.
Yeah, yeah. This question is definitely not all the
Yeah.
answers to do right now. I think my main thing should be right now getting those 500 and 600 questions all like different ways.
See, your overall concepts are good. So there is no doubt about that. So you will definitely score much higher. You have to focus more towards eliminating any casual mistakes.
Yeah,
And if there is something that you don't know as a concept, you have to understand that part.
yeah. I just want to get to a point where I look at a question and I know exactly what type of question is it, so I can, instead of trying other methods, go to the method that you think is the best.
Yes, correct.
Yeah.
Okay. Now, uh, hmm, let's see a question. Okay. How will you do question number 170?
Yeah, I got a question like this on the my practice test.
Okay.
So one is insufficient
One is insufficient. Okay. And
because
why?
you take n. Hold on. No, actually, one is sufficient. Hold on. Because you take let n be equal to 60, 61, 62. Here in this
Hmm.
case, 100 digit of 10 into 60 into 61 into 62 will always give you 6. So
Correct. Very
the
good.
the statement is okay, is taken as true, and so tens digit has to be 6 to be able to get
Correct.
the hundredth digit.
Yes. Information given in the statement is always true,
True, yes.
and any information given in the question stem is also true and is universally applicable for both the statements.
Okay. Yeah. And now going to the second statement. The tens digit of n plus 1 is 7. So obviously let n be equal to 69. And so it's 70, it's 1, but n can be also equal to 71. So n can be, so the tens digit of n can be 6 or 7.
Perfect. That's right.
I just like need to slow down and look at the question properly.
Yeah. So see, what happens is if somebody has good concepts, it always makes sense to give another 5-10 seconds to the question.
Yeah.
What I have figured out is your concepts are fine. So you should give yourself another 5-10 seconds
And
for every
rationalizing.
question.
Yeah.
And before moving on to the statements, read the question very carefully. If it is a data sufficiency problem, rephrase the question what is asked into something more meaningful that makes more sense to you.
Mm.
And when you have all the information available with you, then you move on to the statement. Rephrasing a question is very, very important.
Yeah. So when I'm doing this, I was looking at this. Only topic that I should be looking at right now is number properties, no, from your list.
Yes, yes, yes.
Okay. Not digits and stuff like that. Or
So we are actually doing digits now.
yeah, so that's why I was. If you can just go back to the topic-wise questions for a second.
Yeah.
Yeah, this one. So here now in this list, I should be looking at number properties and digits and decimals.
Yes. So chapter number 3 and chapter number 1.
Okay. Okay.
These two. Yeah.
These all I should do. Okay.
Yeah. And depending on if you can do maybe a good number of questions, then I can share. You must be having all those. I think we discussed about this. All the previous editions of Quant
Yeah,
Review.
mostly.
Okay. Okay. Yeah.
No, just give me like as many practice questions. I'll just do all of them, as many as I can.
Okay. So I'll share the topic-wise listing from those topics, from those books as well.
Mm.
So can you try question number 148?
Hold on. Can you just repeat what you had said about? Oh, it was 2 and 5, na?
Yes, right.
Yeah, sorry, I forgot that. Yeah, terminating if it is. So then, obviously, two is sufficient.
That is correct.
I mean, this question would take so much longer to do.
And when we discussed to figure out terminating decimal, it is only about denominator. We are not concerned about numerator.
Yeah. So if we know two, you have the answer.
Yes. So since S is 2 to the 2,
Yeah.
it has only 2s and 5s, although no 5. So therefore, statement 2 alone can answer the question.
Yes.
Okay. Okay. How will you do 133?
I mean, I would take numbers and try it, but I think the question is which ones matter? Does the tens digit matter or the units? And the tens digit, I mean, matters if it carries over.
Yes, perfectly fine.
So I'm guessing one, but I would still have to try it out. I mean, I don't know if I don't know how you would approach it. Um, So is it just is the answer one? I mean, A?
Yes, that is correct. So it is all about whether we have a carry or not.
Yeah, carryover will come from the tens.
Yeah. So if there is a carryover from units place digit, it doesn't matter. But if there is a carryover from tens place digit, then that will change the hundreds place digit.
Yeah.
Yes, that is correct. Okay. Now there are a couple of questions from the first chapter, which are actually good. Not sure. Yeah. How will you do question number 191?
The 20 or let's say 21 minus 5, 19, 19, 20. See?
See. minus 20, minus 19. Yes, that is correct.
I took positive and negative values of.
Yeah, so yeah, okay, just a second. So the reason why I asked to try this
Am
question.
I trying? As in, am I using the wrong method?
So no, the point is there are two type of questions. One type is could be scenario, and the second type of question ask for the must be scenario. In a could be scenario, you will be given one possible answer choice and you have to figure out.
Yeah.
In a must be scenario, like on the right, question number 195, if you see,
Yeah.
which of the following must increase? So they always ask these two type of questions, must or could. In could, there are multiple possibilities and you have to figure out the possibility that is actually so you have to figure out all possibilities and then choose the option accordingly. Must increase, you have to you have to try and rule out all possible scenarios, but if you cannot rule out any scenario, then that will be the answer. We
Yeah.
will discuss a few questions on must be scenario as we move along.
Okay.
Okay. Okay, and how will you do question number 204?
204 if n is equal to 4p. But isn't that the I mean, like, that the number is divisible by 1, 2, and 4p. So 3. How many? Acha, so two evens. Just one second. 1 into 4p, 2 into 2p, 4 into p. So even now, just see. Let me, p is odd. So 1. How many different positive even divisors does n have, including n? 4.
Yes, that is right. And why?
I listed them out. So 1, 4p, 2, 2p, 4, and p. P is a prime number greater than 2, which means p is odd. So then if you see, it'll be 4, 2, 2p, and 4p.
Perfect. Now, whenever you are given a generic term, for example, n is equal to 4p and p is a prime number,
Yeah.
now greater than 2. So then it actually makes sense to use an actual number in place of p. Because if it is true for that actual number, it should be true for all possible prime numbers.
Yeah.
Otherwise, they would not have asked this question.
Yeah. Basically, if they didn't give that p is a prime number greater than 2, then there could be multiple divisors.
Yeah. So basically, it is the point n is equal to 4 into 3 or n is equal to 4 into 5. It doesn't matter.
Yeah.
So all of these will have the same number of even factors. You can take any prime number.
Mm.
So take the smallest and get your answer. Does it make sense?
Yeah. Yeah.
Why? Yeah. Okay. Okay. Now the next is different type of sequences that are given.
Or AP and GP.
Yes.
So what are they, just like, just this is what they do all day, just make new GMAT questions? People
Who?
like the GMAT prep people, they just like,
Yeah, yeah, yeah. So they have now they have a very solid team. Every question they make, they get the question verified by 5,000 different experts.
oh really?
Yes. Every single question that makes it to the pool of those questions, question bank of GMAT, that is verified by 5,000 different experts.
And like they just, this is what they do for a living. make GMAT.
Yeah, so they are not doing anything for a living. They are just doing for luxury.
Oh, really?
They are making hell lot of money.
Well, yeah, because we're basically paying them so much money.
Yeah,
What a great way of this is like we're paying them to torture us.
yeah. There are people who have taken GMAT like 10 times.
Yeah, I wouldn't want to do it. Some people are just good at it, so it's like it's fun for them. If you're good at something, then you enjoy it.
Um, I don't know. I personally have taken the GMAT 7 times, but that is because I have to take, because that is kind of the minimum requirement that I have to fulfill.
Yeah.
So sometimes we have to do that, sometimes for fun. Now I have a student, she's in Atlanta. Before coming to me, she has taken GMAT 8 times.
Really?
Yeah, so for the last 2 years, she was trying and trying. Every third month, she's taking GMAT. So now we worked for like 3 4 months. She very recently, 4 5 days back, she wrote the test. She got a 680. She actually wanted a 650 plus score.
But she had to take it 8 times.
Yeah, the first time she took, she got a 280.
Oh my God.
So, like,
Like it's
in,
not relative for everyone, right? Mhm.
yeah, see, Indians generally fare better. Reason being, maths for Indians, it comes naturally.
Yeah.
Now, so that makes half of the job easy.
Easy. Yeah.
Now, whatever, and I feel that when I'm working with an Indian, so I have to explain anything only once. But if I'm working with a European or an American,
Mm.
I sometimes have to explain one very simple thing 10 times.
Really? That's interesting. I didn't realize that their maths was this much weaker.
Yeah, it is. Now you ask anyone.
But
I
their
have a lot of
grammar is
students.
better. Like
Come again?
critical reasoning comes to them faster.
Yes, that is true. And now that depends, like the kind of educational system we have in India. So maths. Everybody does maths,
Yeah.
and you check the education system in US from grade 3, they are reading novels.
Yeah.
There is a student of mine whose younger sister, she's in grade 5, and she reads 1000 pages every single day.
Yeah.
Now if somebody is reading that much,
Yeah.
obviously the English will improve.
Yeah. Yeah. Much more than the math.
Yes. So they they are putting a lot of stress on the English part.
That's right. Also, just a reminder, will you please connect me to the faculty who handles vocal?
Yes. I'll do that. I'll drop an email marking both of you.
Yeah.
So I'll do that.
Uh, yeah. I mean, yeah. I just want to like get a sense of just want to make sure both of them are going simultaneously. So I'm not.
Yeah. I'll do that. So I'll do it over the weekend. So
Yeah.
actually, like yesterday, I started taking sessions from 8 a.m. my time till 12:30 a.m. today morning
Oh God.
without any break. So sometimes
That's
it's
a
really
lot.
really hectic.
Yeah.
See, everybody has booked the dates for 28th December, 26th December, 2nd
Uh,
Jan,
so
1st Jan.
that's why you're very busy getting finished with the
Yeah.
okay. Maybe you
So
just
maybe
go on the new, as in not freer, but like just a little less backed up for January.
so. Post 4th of Jan. I think I'll be relaxed. I think so.
Okay, okay, great. Because then at least then I can at least think of doing if I'm doing 2 classes a week, then I can do one 6:30 a.m. and one evening class. So at least that will give me some just and that I can talk to you after the fourth. Till then, I'm happy
Yes,
doing
yes.
30 AM classes. No
Yeah, yeah. That's fine. Okay. Now, sequences. What do you understand by sequence?
problem. Well, I know that a sequence has a number of terms that either they have like they have there is like the second term is like a certain constant more than the first term in AP, like
In an AP. Yeah,
A plus D, A plus 2D, A plus 3D, and where A
perfect.
is the first term, and then D you can say is the common difference between the terms.
Very good.
And then the last term is equal to A plus n minus 1D.
Very good.
And then you can also calculate the sum of the first n terms, which is what they usually ask on.
Hmm.
I know this, so it'll be n by 2, 2a plus n minus 1d. And then
Very good.
that, and that's AP.
Yeah. In general, any sequence is where we have a fixed rule that is applicable on subsequent terms.
Hmm.
Like if we are talking about arithmetic progression, then we know the characteristic feature of arithmetic progression is the common difference.
Yeah.
If we have first term as A, then the first term differs by the second term by a fixed difference. That is arithmetic progression. It will follow the same. You have mentioned all the terms as well. A plus n minus 1 into D. Now,
Yeah.
there
Oh,
can
the
be,
number of terms. Yeah.
yeah, there can be, I can say first term is A. I can say, okay, second term is multiplied by 2. Third term is multiplied by 4. Fourth term is multiplied by 8.
So
That
you
is, I am
multiply.
multiplying everything by 2.
Yeah.
So here I have a common ratio.
Yeah.
So here T2 over T1 is equal to T3 over T2.
Yeah.
So this is a sequence. Now, the sequence that we study, and the sequence is actually tested a lot on GMAT, is sum of first n positive integers. It is also an AP because if we are adding 1 plus 2 plus 3, we know there is a fixed difference, common difference between subsequent terms.
Yeah.
So how? So what is the formula for this?
So in this, wouldn't we just use the formula of n by 2, 2a plus n minus 1d?
We can do that. So 2a will become 2 into 1 plus n minus 1 into d is 1.
Yeah.
So this multiplied by n by 2.
Yeah.
So this is n by 2 times 2 plus n minus 1
Which is uh, n. Oh, acha, n into n minus 1 by 2.
plus 1
N
by
plus
2.
1 by 2.
Yes. Sum of first n positive integers is n into n plus 1 by 2. So you, instead of using the AP formula, you straight away use this formula.
Okay.
What is the sum of first n squares of positive integers?
Mm, the sum of uh, squares, like
Like 1 square plus 2 square.
like it'll be like a into 1 minus. Uh, are you asking me GP sum?
No, no. Squares. 1 square plus 2 square plus 3 square.
No. That I don't know.
So this will be n into n plus 1 into
Oh
2n
yeah,
plus
2n
1.
plus 1 by 6, I think.
Yes,
Yes,
very good.
n into n plus 1, 2n plus 1 over 6. Yes.
So
Cubed
you're
is,
still
I think it's I learned long time ago. Uh, I think it's like n square into n plus 1 square over
yes, perfect. So it
2.
is actually uh, whatever we have the formula here, it is the exact square of this formula. N into n plus 1 by 2 whole square.
Whole square. Hmm.
Right?
Yeah.
Okay. Now, let's say there is a tournament organized having 10 teams.
Hmm.
And the tournament is designed in such a way that each team plays every other team exactly once. How many matches were played in the tournament?
9 factorial. Mm,
9 factorial. How?
9 games. How, okay, how many plus? I mean, sorry. Like 9 plus 8 plus 7 plus. Because team 1 played 9 games, team 2 played 8 games.
Hmm.
So basically, I'm adding 1 through 9.
So if
1 plus
team,
3 plus.
okay, so if second team is playing 8 games, so every team has to play 9 games.
Yeah, but we're already counting. One is playing 9 games, two is playing. Two and one already have played that game, so you've counted it in that first game.
Yes, correct, correct.
That's why you have 8, and then three has played 2, and three has played 1, so it becomes 7. So
Hmm.
you just do, and then you use a formula n plus 1 by 2. So
Sum of first 9 positive integers.
yeah, so 9
9
into
into,
10 by 2, so 45 games.
yes, very good. Okay, that is good. Now, sequences can be a lot different. For example, question number 124. I'll show you the question. This one.
Oh God. Each. So distance between A and B is given, distance between A and C. Acha, now they're saying it should be 30 of them.
Hmm. Correct.
So N becomes 30.
Correct.
N is equal to 30. A is equal to um, 465?
How?
Isn't it n into n plus 1 by 2? Am I? Hold on. Let's see. Here, look, 5 times 5 is giving you entries of 10.
Hmm.
Now, how do I really, I don't know what I'm trying to do. 5
Now we are given that each dot in the mileage table
represents the distance between the pairs.
an entry indicating the distance. If there exists a distance between a pair of cities, there will be an entry
Yeah.
with a dot. Now, if the table were extended to represent the distances between all pairs of 30 cities, that means here it will be F, then G, then H, and so on. And here also we will have F, G, H, and so on, like this, right?
But F and F won't have a dot.
F and F won't have a dot. That is true. But if I have an F here, then A and F, there will be a dot. B and F, C and F, D and F, E and F.
So 29.
Yes. So first city, first column, if you see, there is no dot.
Yeah.
Because A and A, there will be no dot. Starting with B, A, the row A will have dots. Till, so except one column, 29 columns will have a dot. For B, there will be no dots in 2 columns. So 29 plus 28 plus 27
Hold on.
till 1. Why? Each distance were to be represented by only one entry.
Can you just hold on? So I understood F tak. You showed me that is. So now if you take G, G will have dot there all the way down. Okay.
To
Oh,
F.
oh, you're looking at it column wise. So the
Yeah.
first one will have a total of 29. Then the second one 28.
So,
Acha,
so
because
in the first column, there is 0. In the first column, there is 0 entries.
yeah.
In the second column, there is 1. In the third column, there are 2. Fourth column, 3. So just one less than the number of columns.
Yeah, and then this one is next one is 4.
Yes.
Then
Then 5. Then 6. Right?
yeah.
So we are adding from 1 to
Yeah.
29.
29.
Because
Not
29
150.
dots will be in the 30th column.
Yeah, 29. There'll be one less.
Yes.
So n becomes 29 actually.
Yeah. So 29, 30 divided by 2. So this will be 435.
435.
Right?
Yeah.
Okay. So shall we stop here?
Yep.
And we will continue with sequences and we'll try to finish off with the entire number system in the next session.
Okay. Fine.
Okay, so we today is Friday, so we will be meeting 6:30 Monday.
Yeah. Monday morning.
Perfect.
Okay.
I'll see you on Monday then. Just drop me an email if you can.
Yeah, I already sent it.
Okay, fine. Thank you.
Okay. Thank you.
Okay, bye bye. Have a good day.